All right, let's dive right into this explainer on how AI is fundamentally rewriting the rules of the entire industrial sector. We hear so much hype about artificial intelligence these days, but today we're cutting through all those buzzwords. We're looking directly at concrete mechanical reality, mapping out exactly how AI is integrating with industry and charting the roadmap all the way to the year 2035.
We're kicking things off with this quote right from the source material because it just perfectly captures the sheer magnitude of the shift we're about to explore. We aren't just talking about a faster calculator or, a slightly better software program. By harnessing data, AI is actually equipping physical industries with real perception, cognition, and decision-making capabilities. It's literally a whole new productive force.
And we're at a massive turning point on the factory floor right now. Physical industries absolutely cannot keep relying on just, building bigger factories or throwing more people at a problem. The new industrial revolution demands a total shift away from relying on massive scale to being powered entirely by extreme efficiency and digital innovation.
So, here's our game plan for today. We'll hit the new industrial revolution, the 4 stages of AI, the 2-curve pattern, redefining teamwork, and finally, wrap up with that 2035 vision.
Section 1. The New Industrial Revolution, the Transformation Paradigm.
Okay, the crucial point here is that industries globally are facing some seriously complex challenges. We're talking growing resource and environmental constraints, skyrocketing labor costs, and these huge, stubborn data silos. The traditional model of just scaling up production, what they call the scale dividend, is pretty much dead. AI is now viewed as the only viable pathway to jump from a quantity-based model over to a quality-based model. It's about unlocking an efficiency and innovation dividend.
Section 2. 4 stages of AI. The evolutionary bridge. If we trace the evolution according to industry consensus, AI develops in 4 really distinct stages. First up is perception AI. It just recognizes things. Then comes generative AI, which creates things. Third is agentic AI, which can actually execute complex chains of tasks. And finally, physical AI, which completely breaks the boundary between the virtual and the real using robotics. Right now, we're crossing a really critical bridge, stepping out of generative AI and making our way toward agentic and physical AI.
But there is a huge application gap right in the middle of this evolution. While perception AI is highly mature, like think of machine vision spotting a micro defect on a semiconductor line, agentic and physical AI, they're still very much in the exploratory phase for heavy industry. They're held back by critical factors like model hallucination and general safety in real-world deployments. A factory literally can't afford a hallucination when operating a multi-ton stamping press, right?
Section 3. The 2-curve pattern, the secret mechanic of deployment. Think about your own business for a second. Deployment isn't happening uniformly across the board. It's actually happening at completely different speeds depending on the type of model being used, which creates this totally distinct 2-curve pattern across research, manufacturing, and marketing. It breaks down exactly like this. Small models absolutely dominate the middle, the actual manufacturing processes, like calibrating a robotic welding arm. And why? Because they offer highly precise execution, low cost, fast speed, and they are super stable in resource-constrained environments. Large models, on the other hand, dominate the outer ends of R&D and marketing. They excel where open, creative generation and complex language understanding are needed, like drafting up product specs or writing ad copy. The big takeaway here is that these models do not compete with each other. They actually mutually reinforce each other. It's fascinating. Large models act kind of like a teacher, transferring knowledge down to smaller models through a process called distillation. Meanwhile, the small models help ground the large models by efficiently executing tasks and feeding back real-world constraints. In fact, survey data shows that a massive 92% of industrial enterprises are currently adopting a strategy that combines both, best of both worlds for sure.
Moving to Section 4, redefining human-machine teamwork, the shift in roles.
So let's address the elephant in the room: human jobs. We are undergoing a massive inversion in how we work. Historically, we operated in a computer-aided paradigm. Humans did the heavy lifting of design and execution, and computers just assisted. Well, we are now moving toward a human-aided paradigm. Computers will undertake most of the actual product design and work, while human engineers simply issue requirements in plain language and pick the best final outcomes.
But don't worry, this isn't some overnight takeover. It's a highly structured step-by-step promotion. In Step 1, AI is just a helper, basically inputting data. In Step 2, it levels up to a co-pilot, predicting risks and simulating scenarios while a human reviews it. And finally, in step 3, the AI takes the lead as a fully autonomous agent, automating the workflow completely.
The contrast between these workflows is just night and day. In the old assistant model, humans are doing the actual manual operations. In the new agent-led model, the AI handles the task analysis, execution, and data summarization on its own. Ultimately, the human's role shifts entirely from a manual operator to a high-level supervisor. Imagine one person managing a whole fleet of AI agents, only stepping in to handle exceptions or give strategic direction.
And this workflow shift, it redefines the entire industrial software business model into what's being called Result as a Service, or RaaS. In this near future, you won't need to understand complex AI algorithms, and you won't be buying traditional software licenses either. You'll just pay for the tangible, measurable value the AI creates for your factory line. The provider delivers the result, pure and simple.
And finally, Section 5, the 2035 Intelligent Vision, charting the ultimate future.
Okay, let's look out a decade from now. By 2035, the source document predicts a world where the deep integration of industry and AI fundamentally empowers the core elements of production. And this isn't science fiction, folks. It's the projected end state of that two-curve adoption pattern we just talked about. They categorize this ultimate future using what they call the 5 widths.
Let's break down these 5 widths across the industrial spectrum. AI will align with human cognition to slash errors. It'll integrate directly with autonomous machinery to pretty much eliminate unexpected downtime. It will dynamically coordinate materials for a zero-waste supply chain. It'll share intelligent process methods, turning human expertise into reusable digital rules. And lastly, it'll interact seamlessly with the physical environment through advanced robotics.
Now, I know it might sound a bit intimidating to hear that 25% of repetitive and high-risk manufacturing jobs globally could be replaced by embodied intelligence. But to put that into perspective, the source material actually positions this as a massive, much-needed labor force upgrade. It pushes human workers entirely out of dangerous environments and up into much safer, higher-end R&D, supervision, and creative design roles. And the financial and societal ripples of this intelligence layer stretch way, way beyond the factory floor. By 2035, we are looking at a $270 billion humanoid robot market, a staggering $7.2 trillion autonomous vehicle industry acting as a sort of third mobile space, a $1 trillion smart building market, and an optimized, greener planet with 11.2 terawatts of renewable energy capacity, all managed seamlessly by AI dispatching. To sum up this incredible roadmap, the ultimate goal defined here is true industrial AI democratization. And that means moving beyond siloed innovation, where only massive tech giants reap the rewards, and shifting toward a system-level intelligence, where small and medium enterprises can seamlessly plug into industrial knowledge graphs and share in those productivity dividends. So I want to leave you with this final provocative thought. Knowing this timeline, understanding the difference between small and large models, and seeing the massive shift from computer-aided to human-aided design, how are you going to prepare your own workflows? Will you step up to become a manager of intelligent agents, or will you just be left as a spectator to this new industrial revolution? Thanks so much for joining me on this explainer, and I'll catch you next time.